IFS is powering big enterprise, big ideas, and big change. With technology that enables companies to innovate and grow. With unparalleled industry depth that provides a way to create value by joining the dots. And how companies engage with their customers, empowering their people and use their assets so that they can deliver when it really matters at the moment of service. Touching our lives and improving the way we do business across the world.
From the moment we wake up.
To how we travel.
To the business we do.
And how we care for our world.
IFS is leading the way and empowering thousands of the world's most progressive brands. Let us help you be your best
at the moment of service.
To the perfect memories without hindering yours. The only proof of our presence will be the images and the moments that go beyond expressions for you to cherish for a lifetime. Now you see me, now you don't.
Good evening, fellow coders. In our daily lives, we constantly encounter intricate challenges. Algorithms at the heart of computer science offer systemic, step-by-step solutions to tackle these complexities effortlessly. Welcome to day one of Logic Labs, a two-day online workshop series organized by the IEEE student branch of IIT in collaboration with the IEEE Computer Society of IIT, IEEE Women in Engineering Affinity Group of IIT, and IEEE Robotics and Automation Society of IIT. I'm Sesandi Rajapaksha, your moderator for this evening. Logic Labs is dedicated to enhancing the knowledge of our IEEE Extreme enthusiasts, and today we will explore the fascinating world of data structures and algorithms. Today's session is immensely valuable for coders who want to conquer coding questions with ease, transforming chaos into clarity. Now, without further ado, allow me to introduce our esteemed speaker for today's session, Mr. Kavishka Nirmal, a software engineer in the Field Service Management team at IFS. Now, before we start, The Slido link is now available in the Zoom chat, so please feel free to drop your questions there. Stay tuned until the end of the session where we will address all of your doubts. I shall now hand over the floor to Mr. Nirmal to grace us with his knowledge and expertise in the world of data structures and algorithms.
Thank you, Shanti. Right. Hi, everyone. Good evening to all. I'm Kavish Nirmal, and I work as software engineer, basically focusing on mobile app development at IFS. And I graduated from University of Moratuwa. That's a little about me. Now let's get started with today's topics. Hope you all already know what is the topic is today. Before we start talking about the today's topic, which is data structures and algorithms, let me give you some advice. The advice is it's important to understand why you are learning something and where you might use it. Think of it that way, knowing the reason behind your learning help you learn better. Sometimes we wonder why I'm learning this. Is it even important? So when you know why, you all see the value in that context you study. So whether this data structures or algorithm or anything else, ask yourself why you are learning it and find it, searching it. It will make your learning experience more meaningful. So before we dive into our topic, as I mentioned, let me explain what is data structures and algorithm and what is the context of this area. So first we look at, let me share my screen. Hope you all see my screen. Right. What is data structures? Think of data structure like containers or special boxes that help you organize and store different types of information. Just like you have drawer to keep your clothes or books in your store your box. Data structures are tool for organizing data in computer in that way. Let me explain more. Imagine a restaurant or hotel that makes different types of meals. They store these meals in big containers in their kitchens. Now they serve these meals in different ways. Some people dine in, others take their food take away, and sometimes they serve meals in their private rooms. Uh, the important things, the basic thing is all the meals are in those big containers in their kitchen. Uh, what changes is how they serve the meals based on why someone wants to how someone wants to eat. So get them. They can't serve meals for dining the same way as meal for takeout. It's different. Data structures also bit like that. We have a lot of data stored in our computers and system in databases or storages, just like meals in the containers. But depending on why we need this specific set of data, we have to handle them differently. So data structures help us to do that. The data structures help organize, access, and work with our data according to our specific purpose. So now you already know what is the data structures, why we need to learn these data structures. So I will deep go into that. There are different types of data structures. And I get some example arrays, linked lists, stack, queues, and other so many different data types, data structure types. First, I get the array type. The array. First, I explain what is the array, and then we can move to the programming example. Arrays like I think of an array like row of boxes. Then each box can hold something like something you want arrange. You can have many boxes line up in a row, and each box is numbered. So if you want to find a specific box, you just remember the which number is it in row, then you can find it. It's like having a lineup numbers lockers in a bank. You can put your things in each locker and find them easily by knowing the locker number. Arrays work same way. For data in computer, there are like rows of numbered boxes where you can keep your things. We go more. When you create an array in computer program, like in Java, I'll explain with the code example. I prepared some codes before because we have limited times. We can't explain line by write codes in line by, so I prepared some codes and explained them. Uh, in the Java, you basically telling the computer to set aside specific chunk of its memory. Think of its reserving series of memory slots like drawers in reserve to store your data. This is the line. We say the computer, this is my array. Reserve a chunk of storage in our main memory. I have to send 5 data in that memory. End of the when we create the each of these memory slot has a number like 0, 1, 2, 3, 4, like starting from 0. So the first slot like slot 0, the next one is slot 1, and so on. These slots are where you put your data. You can easily access, insert, delete, and update the data these slots by using their slot numbers. Likewise, I insert data into array 0 slot number 10, arrays number 1 slot number 20, array 2 number 30. Then I can access them by addressing these slot numbers like this. You can easily access those numbers by addressing a specific slot number. Then we move to the linked list. It is a bit different rather than arrays. Think of linked list like a chain of connected blocks. Each block has a piece of information inside it, and it's connected to the next block in the chain. You start with the first block, follow the chain, and you can see what's the next block one by one. It's a bit like having a string of lights as well. One light is connected to the next. In a linked list, data is stored in these blocks, and they are all linked together. So you can easily move from one piece of data to the next. Linked lists are handy for storing, organizing data in specific order. What's the difference between these arrays linked lists is the main difference is with the array, it's a bit like having numbered lockers. You can easily find what's in the locker because each one has unique number. So if you need something specific, you go directly to that numbered locker and grab it. It's like looking up word in dictionary with page numbers. You can jump straight to the page that you want and you can see the words. But with the linked list, it's bit different. It's more like a chain of connected blocks. Each block has something in it, and they are linked together. You can't just jump to a specific block because there are no numbers or address on them, like arrays. You have to start at the first block and follow the chain one by one until you get the block you are interested in. It's like reading it's like reading a book from the beginning and find particular chapter you're interested in. Like the way linked list work, different to the arrays. So the key difference is that arrays give you quick access with numbers, while linked list make you travel through the chain, find what you need. So then you have question, why we need that linked list? Because then arrays we can quickly access any element by addressing their slot numbers, but in the linked list we can't do that. Uh, we have to travel one by one to get interested element in the linked list. So there is a reason why we use linked list. As I mentioned before, when I talk about the data structures, I said that we want different data structures according to our purpose. So can you remember when I define an array, I give it a length like this. I give like 5. Then we are stuck with fixed number of slots that we can have in our array. But in the linked list, we don't have this problem. We can add any number of elements to the linked list just by adding link to the last element. I will explain in the code example. Then apart from that, if you want to insert or remove something in the middle, you just need to change couple of connection in the linked list. Then we can delete or add in something, add in element for the linked list, like talking out, adding one element from your string. But in an array, it's like empty the locker, not just delete the element, we empty the locker, or add or remove something. So which can be quite odd. That linked list does not do that. We completely remove or add in one element by changing couple of connections in the linked list. So I explain it bit with graphical way. So I'll get my whiteboard. As I mentioned before, when we initiating an array, the computer tells to the tells to their main memory RAM to reserve some space for this array like this. I get brush tool. We think this is our main memory. Main memory organized as a cells. When we define an array like AR1, size I use 5, like this, then the computer reserve 5 slots, 5 cells for this specific array in linear order. This is slot number 0, this is slot number 1, this is slot number 2, this is 3, this is 4. But in linked list, they do not do that kind of way. When we create one link to the linked list, it can be stored in anywhere. The second link, it can be stored in anywhere. But we have an address to access our next next link. Then we can say this is address number X, this is Y, this is our data we inserted in our linked list. We tell this is 20, and this keep the next element address as well, like Y. Then the linked list can easily access their next element by this. That's the main difference between array and linked list and how they works in computer architecture. So I'll go through the programming example, and then you can easily understand what I tell. This is a code example for linked list. First, we need to define so what is the node? The node is one element in the linked list. Like we have in the arrays, we have ARR1, ARR2, ARR0. Like we can address the elements. There is a in the linked list, we call that one element as node. We define the node in the beginning of code. Node has two data. One is what we stored in the linked list, and second is what is the next element of this not consist. Like we define integer data in our linked list, then we define integer data and not next. First, we have one element in our node, so we have in our node next is null, because we haven't any second element till we inserted them. So when we first define the linked list node, we have to define data element, data variable, and as well not variable. Data variable can be our stored data, and next variable is stored what is the next element address on it. So this is how we add elements into the linked list. Rather than arrays, we just address in the specific slot number and just put in them into array list. But in the linked list, we do that in different kind of way. Like that, we have to create the new node. We define in our beginning of the code. We have to create new node. Then we have to then we check what is the head. Head mean what is the first element of the linked list. What is the head address? What is the head address contain? If it is null, head is new node. This means we are creating first element of the linked list. If it is head is null, there is no any other elements. So head is our created new node. If else, we have to loop what is the last element, what is the null element, what is the address be null in the linked list. It is the last element, then we can add our next element in the list. Likewise, we have to add first not in our linked list, then after that we can add our values in the linked list. Like this is the next one, how we delete the one element from linked list. Same as before, we need to check is there any elements in the linked list. For to check that, we check in what is the head. If it is head is null, there is no elements in the linked list, then we can return exit from the code. If it is there is a head meaning first element has data, so we know that there are another elements can be in the linked list. So we have to loop what is the next element. So we have to loop element by element by addressing next address which in the each element. This is the code. What we do, we check what is the current element. If it is not null, then we check the if what is data we want to delete in the current node. Then if it is not, when we move to the next data. Likewise, we loop in the list and we find the what we know need to delete. Then we can delete the node. To delete that, we just do we erase the address of linked list by like this. I will display it. In here we check in the value in current node next dot data. It's mean our next node has a specific value we find into delete, which pass into this method. Then if it is not, we can move next value. If it is there, we can delete this value. As well as to display in something, display the linked list, we have to traverse into the linked list rather than arrays. We can, in the arrays we can just print it by addressing slot numbers, but in the linked list we have to loop our linked list by each node like this. Then I run the code. This is my main method. I just created one linked list and add some values. This is why we add function 10, 20, 30. Then I can display one by one likewise. Then as I mentioned, why we need to link list, in the we can if I in the way when we use arrays we define fixed length, but in the linked list we not define the fixed length, and we can add in any element of the at the end of the linked list by just adjusting some couple of connections. That's how works arrays and linked list in data structures. We use them in various purposes. As I mentioned, what is the purpose we can select what we need, array or linked list. The both are like same data structures, but there are few difference. Like I mentioned, according to our purpose we can use them at our programs. Then I have another two data structures to discuss. We have to discuss about arrays and linked lists. Then I have to discuss about stacks. There is another data structure type is stack. Think of a stack like a stack of plates. You can add a plate to the top of a stack or take a plate from the top. The last plate you put on the first one you take off. It is the last in first out system. Have you heard about it? I think you have heard about it. Last in first out system. The stacks works as last in first out system, just like when you pile up dishes in our kitchen. In the computing context, a stack is a data structure that works the same way. Like that, my example. You can add data to the top and remove data from the top. It's handy for tasks where the order of items matters, like tracking our web or mobile application back button history. When we tap up the back button, we get our last in activity. In the web browser as well, when we tap on our back button, we first out the last accesses page. Likewise, or even we can keep in track out our undo history in text editor. When we undo anything, we can get last edited one for our text editor. So stack are like a virtual stack of plates for computers to keep things organized in that way. So I'll do a code example for that as well. Clear all things. I already prepared code snips because we can't code line by line at the limited time. So I'll paste it. This is the part how we define the stack in the Java programming. We have max size, like how much we can stack on our stack, how much data we can stack on the stack, and we have top variable. Top variable means what is the topest element in our stack. Then we can create a stack element like same as linked list. We have some operations to add in, deleting, and searching, display elements in the stacks rather than array. So in the stack, to get element, the element getting we call push event. If we want to get some element from stack, we call it push event. Sorry, if you want to place a element in the stack, we call it push event. If you want to get element from stack, we call it pop event. If anyone has experience in Flutter, you can you experience that if we click in back button or we overriding back button, we called pop method to get last in stack, last in screen we have visited. Likewise, in the stack operations, if we want to get place in some element in the stack, we called it push event. If you want to get some element from stack, it's called pop event. In here, you can see in push event, we pass a variable, a parameter, because the push event, we place some data in stack, but we haven't any parameter in pop event because we don't specify what we need to pop out, because every time we always get in last element we have visited in the visited or inserted in the stack, like a stack of plates, stack of books. If we need to push any element to the stack, now I'm telling the method names directly. If we need to push any element for the stack, we first need check if the stack is full. As earlier mentioned, we have defined a max size. If the max size reach, we can't push any elements for this stack. First we need to check if it's full, then we can't add any element. If it is not full, we can add top value. When we define this stack, we have create a variable like top. Top meaning what is the topest element in the stack. Then we can change the top value by adding our inserted value. Then we can update the stack top value by adding this way. If it is full, we can't add any element for the our stack. When we go to the pop method, this also we need to check if it is empty, because it is empty stack, we can't pop out anything. So first we need to check, is it empty? Is it not empty, we can decrease the existing top value. If top is now 20, we can take, if it is top value is 25, I mean top address is 25, we decrease this and top get 24, then the 25th value return. Likewise, sorry, 25th value get deleting, and stack operations top value is getting 24. Likewise, then we can pop out these values. As the link, same as the linked list and array list, if we pop out any element, we can't get it again, we have to insert it again, push it again. Likewise, then we talk about some operation in there. So I run the code. Yeah, this is how I created the stack, and I push some values and I pop a value. When we push the values, they stored in like first one is 10. You can last element is 10. Second, then 20. Top element is 30. When I pop out one element, the top element will be 20 this way. Popped item 30. So we can, if we get the top element now, we can see it is 20. That's the stack operations, how it's performed. So when we move to the next data structure type, it's called queue. Queue work same, not same as stack, but both like array list and linked list, like same behaviors. Same, the stack and queues also has same behaviors, but there are completely different methods, but we can see as the same behaviors. Imagine a queue like a line of people waiting for something, like dancehall polling. The first person to arrive the first to go their packs, and last person arrive has to wait till their turn at the end of the line. It's called the first in first out system. At the stack, we called the operation last in first out system. In queue, we call this first in first out system, because who is the first person come to the queue, he get first pack. Who is the last person came to the line, he need to wait until their its turn. That's why it's called first in first out system, just like waiting in a line in a grocery store, like any other queue we have seen in real world. In computing, a queue is data structure that works same way. You add data to the back of the line, and you take data from the front. It's useful for managing tasks that need to be processed in order to they received. When we get example like printing documents in a printing machine, it's handling as a queue, because what we printed, what we get printed first, it's output first output. What we get print last, it get last output. So queues are like digital waiting lines to help computers to stay organized. So I'll explain the queue code, queue programming example as well. That's my code. Same as stack, we have to define. This is how we define a queue. Same as this is stack. We have to define max size for the queue. How many elements we can store, how many maximum elements that we can store in the queue, and we have two elements called front and rear. In the stack we have only top element, but we have in this queue we have two variables, front and rear elements, because we have to manage queue. When we inserted queue, we have to insert in prayer type in the when we getting the values from front. Because of that, we have both side. We need to both side to do operation since queue. Same as the stack, there are two operations we called enqueue and dequeue. Enqueue mean if we want to add some value to our queue, it's called enqueue. If you want to get some value from queue, it's called dequeue. Like stack, if you want to insert some, we call push. If you want to get some, we call pop. In the queue, if you want to get in some, it's called enqueue. If you want to out some, it's called dequeue. It's the enqueue method. We pass a value which we need to enqueue. But in the dequeue, we not pass value because we can't get a specific value. We have to get what is the first value came into the queue. We have to get that. Like stack, different to stack. Same when we get in queue, we have to dequeue first element came to the queue. In enqueue method, same as stack, we have to check if it is full because we define max size for the queue. If it is full, we can't enqueue any element because the queue reach max size. If it is not full, we can change the rear element by adding our new value. This is the how it's work. We change the rear value by adding our new value. Then the rear comes our new value. If it is full, we can't change the queue. Then in the dequeue method, same as stack, we have to check if it is empty. If it is empty, we can't dequeue anything because it is empty queue. If it is not empty, we check what is the front. If it is front value greater than rear value, then we get front value as 0 and rear value gets as 1. Then we can remove the items. If it is empty, we can't dequeue them. Like in these stacks, we call them in the stack operations. We check if it is empty or not. If it is not empty, we pop out first element. In there, we have to change both rear and front elements because rear elements, if we get one, if we dequeue one element, we have to change rear element as well because it's getting we managing both sides rather than stacks. That's why we want to change both elements in the dequeue operations in queue data structures. This is our main method. I have defined a queue with 5 elements. I have added 3 elements, 10, 20, 30. First elements, what I have added is 10. So we can dequeue 10. Last elements we have added 30. We have to wait until 3 turns to get this 30 value. Then I run this code. We can dequeue first element what I added when the operation performed. Yeah, that's the basic data structures we want to know about in this context. Arrays, linked list, stack, and queue. But there are more data structures we use in when we use in programming, when we create in softwares, when we develop in web services. We have to get some kind of data structures. In your context, you need to better understanding these 4 data structures: array list, linked list, and stack and queue. They are working in different kind of ways, and we use them in different kind of purposes. In that way, we can as the differences between those types, we can identify what is the best data structures what we need to perform any specific task, any specific purpose in our programs or in our softwares. Then we move to. So I explain those stack and queue by graphical way as well, like array and linked list for better understanding. Okay. First we talk about stack. Stack, like this is our first element we have entered to the stack. We can add 10 Then second value can be 20. Third value can be 30. Likewise, we can add our data into a stack element by element, like a stack of books, like a stack of plates. Likewise, if we need to get one value, we can't get value 10, value 20. First, we need to access value 30. That's the difference. Where that's the main characteristic of this stack data structure. If we need to access one value, we have to reach first value, first last in value, not the first value. I added first as 10, second 20, last 30. We can't access first value, we can't access second value, we have to access last value we added into the stack. That's why we call this last in first out system. Okay, then we call about then we talk about queue operations. In the queue, it's like if we enqueue any value, it goes to first at the start front of the queue. We can say it's 10. It's my first inserted value. Then I insert second value. Then case 20. Yes, it has my third value. Let's get 30. Likewise, we can add in more. If I need get element from dq element from the queue, we have to get first element what we inserted into the queue. That's why we call first in first out method. We have to out first element what we inserted first, different to the stack operations. Basically, we have to insert it from rear side one by one. First element come to the top front of the queue, last element go to the rear of the queue. If we need to dequeue something from some value from queue, we have to dequeue first element what we inserted into the queue, we have to out first in this queue. Okay, then this is how stack and queue operation works. When we get to the real-time scenarios in the stores, like we can get Food City or Cargill, something like supermarkets. They manage their stocks in first out method. Like if they have some kind of fruits or vegetables, some things they have to sell first come first. They have to sell first. What are they get first? Like then if we think they have first they have a lot of vegetable, they have to sell them first before they can get ruined. So likewise, we can talk about some scenarios in real time. Think about what are the operations in your uh, in your real time real world. Then you can apply those data structures to get more idea about that. So it's my maybe move to our slides. We talk about data structures, then different types of data structures, and some operations in data structures, bit more. Yeah. The next topic is algorithms. What are the algorithms? So same as data structures, first I explain bit about algorithms, or why we need algorithms, what are the importance of algorithms, then we can dive into the each one by one. First, what are the algorithms? Algorithms are like step-by-step recipes for our computers, like just as you follow a recipe for cook your favorite dish, same as computers follow algorithms to solve problems or perform tasks. An algorithm is a set of instructions that tells to computer exactly what to do in a specific order to achieve some particular goals. That's we call algorithms. So algorithms are crucial in the world of computer because they are the brains behind all technologies we use. Whether it is a search engine finding the best website for you, likewise, then with some example for this, we can talk about in YouTube. When you choose how you want to your playlist sorted, an algorithm in YouTube is like to magical helper. It looks at each video and puts them into the order you want as your view times, as your search in things, whether it's from newest to older or by views. It's like having a arranged playlist just where you like it. That's how algorithms works. There are so many examples. The understanding of the algorithms is computer scientists and programmers like you, because it enables them to create efficient softwares. uh, like it's like being a like chef who knows how cook delicious meals quickly and with uh, the least wastage. Same as the computer context, we can create efficiency and quickly without performance issues and other code complexity, to avoid code complexity by using good algorithm practices. There are so many types of algorithms, like search in algorithms, sorting algorithms. In this context, uh, I supposed to talk about some sorting algorithms and searching algorithms. The sorting algorithms means, imagine you have list of unsorted numbers or any kind of data, and you want to arrange them in ascending order or any order. Algorithms like we discuss in later, bubble sort or quick sort provide step by instructions for doing how to just do that. They ensure the smallest numbers bubble up and list is divided and until it sorted. Before to dive into this sorting or searching algorithms, I just I just create some small kind of algorithm to get more big picture of algorithms. When we get example like, if I'm getting my text editor. Give me a few seconds. Okay. The example is we have to we have to check what is the largest number from two numbers. We have two numbers. We need to check what is the largest number. It's a small example. Before we dive into searching algorithms, we discuss before that this example to how create the algorithm. The example is we have two numbers. We have to check what is the largest number from them, like this. In algorithms, we don't need to use any kind of language, Java or C# or like this. We can just take some language, English, or in if your preferred language. In our context, we get English. Just get English, and we create in a solution for a problem step by step by to achieve our goal. What is our goal? We have to find what is the largest number from two numbers. The basic problem we have solved. We have two numbers. We have to search what is the largest numbers from them. This example for explain how we build an algorithm in simple way. We have two numbers. I get number 1. It's 25. I have number 2. You also can see large. Number 2. It's some 15. There are no any rules when we create an algorithm. There are no rules. We have to use semicolons or double quotations. There are no rules. Algorithm just write instruction step by step to solve a problem by using your preferred language. This is number 1. When we use them in our language models, we have to convert it to that rules and ways we coding them in a specific language. But first, we have to build set of instruction according to the specific problem in our way. Then we can convert it into the Java code or C# code or something. If you want, what other language do you want? This is the numbers we have. Number 1, 25. Number 2, 15. There are some programming structures. I think you already know. There are some programming structures to selection something, to loop in something. Likewise, to do some specific things, there are many kind of programming structures. To select something, we have two selection types: if else and switch case. I think you have heard in programming modules. This is a data structures session, so I not explain about those things. I think you already know, so I use them. I want to check what is the largest one, so I get if number 1 is greater than number 2. If it is number 1 greater than number 2, that's mean number 1 is the largest number. Then we can print number 1. I use some spaces. Or else that's mean else mean it's not number 1 not greater than number 2. There are two scenarios we can get from this side, because we can get number 2 larger than number 1, or both are same. So we can't get directly from else. We have to check if it is same or if it is number 2 greater than number 1. So I check else if number 2 greater than number 1, then we can print number 2 because number 2 is the largest one. Else, to the last block, because there are no any other scenarios. The scenario is there can be happen number 1 larger than number 2, or number 2 larger than number 1, or both are same. Else, we can print both are same. As I mentioned, I not use any programming techniques or any other programming things in this algorithm. This is just instruction what we need to check what is the largest number of number from those two numbers. This is not a program, this is a basic algorithm. I not using any programming techniques or any programming rules in there. I just write what are the instruction, then we can convert them into our program like this. I'm not talking about programming. This is my main method. I write my logic in the inside the main method. I have two variables. Integer number 1 equal 25. Integer number 2 equal 15. Then I check if now I have to use programming techniques according to Java language. Uh, in my right side, there is a basic algorithm. In my left side, I converted them into Java code. Num1 greater than num2. Then I can print largest number is number 1. Give me a second. Sorry. Else if, then we have to check if num2 greater than num1, then we can print num2 is largest number, or else this is the last scenario. Both are same. Yes, so the largest number is 25. We get this this line, right? This is the basic example and basic program for how we create the algorithm and how we converted it into the our programming specific programming language. It can be a Java or C# or something like that. This is a basic one. We have to when we go to the searching and sorting algorithm, they are a bit kind of bit complex more than that. This is a smallest basic thing. So I move to the our lesson again. We are talking in about sorting algorithms. As I mentioned, there are so many kind of sorting algorithms. I get some few example like bubble sort, insertion sort, selection sort, merge sort, quick sort. Likewise, you can find out them and figure out how are they works. Today I explain one or two from this list. First, I get bubble sort with the code example. Then with the code, I explain how bubble sort works. Same as data structures, the bubble I explain later as well. Bubble sort works in different way, and other sorts are works in different ways as per our purpose and our what we do in our program. We can choose what is the best search sorting algorithm we need to use our programs or software we developing. So to do that, you have to get good knowledge about these types of algorithms and how it's work, what are the difference between them. Likewise, this is my bubble sort program. Mm, this is main method. Just don't think about that. This is the method used to sort the array we pass into the bubble sort method. This is the array we have to sort integer array. We have unsorted array 64, 34, 25, 12, 22, 11, 90. And then we need to sort this array into ascending order. To do that, to do this, in this code example, we use bubble sort. Now we discuss how the bubble sort works and what is the key features in bubble sort. We start by looking in the bubble sort. We start by, I don't discuss about these two lines at the first. We start from this line. Later I explain what the purpose of these two loops we used in this program. First, we start by looking at the first two cards in the array, like get 64 and 34. In the bubble sort, we look at the first two cards. If the one of the left is bigger, if left one is bigger, we swap them. If from the first two cards, from the first two elements, if left one is bigger, we swap them. In this code line, look, ARRJ mean our J. This mean our first elements. It's mean 64. Variable J plus 1 mean second element. Later I explain how J comes first element. First thing, J is first time. J is variable J is 64. Variable J1 plus is 34. If J means 64 greater than 34, then we need to swap because 64 is greater than 34 to sort sort in ascending order. We have to move largest element to the right corner. So the first element greater than second element, so we have to swap them. To do this swapping, we use temporary variable to we get temporary variable and we store this first element in the temporary variable. Then we assign second element value to the first element. First we store the first element in the temporary variable. Then we assign second variable into first element. After that, we can assign that temporary second variable to the temporary variable into the second variable. Let me explain again. First, we to do swap in the two elements. First, we need to get temporary variable and we store first element on it. Okay. First we get temporary variable and we store first variable into the temporary variable. Then we assign second variable into first element. That confusing. First element value save with the temporary variable. After that, second element value saved assigned to the first element. Then first element don't have their previous value. Now it's updated with 34. Now in this line, in this when we execute this line, 64 goes to temporary variable and this value becomes same as 34. In this line, this second value we change into the temporary variable. We assign the second value to temporary variable. Just swap in the values. This is the main thing in the bubble sort. First we get two elements. Then we check what is the largest one. If it is left side one, we swap the values because we need to get largest value into the right corner. First we check what is the greatest one. If it is left side one, we swap them. If it is not greater than if it is not larger than left side one, we don't move. We don't do anything. We just stay. Okay. Likewise, we check in element by element. First we 1, 2, again 2, 3, then 3, 4. Likewise, we check in nearby elements. What are the largest one, and we swap them. We get largest element of the nearby elements into the right corner. To do that, we use this for loop. J is 0, first turn, J is 0, that's 1. Second turn, when we comes in the loop second term, it's get J number 1 because it's increment by 1. Then 1 and 2, J and J plus 1, we are checking. Then 1 and 2 check in. If it is greater than that, then swap in. Likewise, we check nearby two couple of elements one by one and swap in both values one by one into in the array. By doing this, we can get largest value to the corner. In the array list, the largest value comes to the corner. By doing this, I can explain in graphical way like this. sorry. This is our array 64. I get I'll get 4 numbers. I'm not getting 7 numbers. I get 4 numbers because getting more time to explain more numbers. I get 64, 34, 25, 12. This is my array to represent in graphical way. First term, as I explained, first we check those two numbers, 64 and 34. What is the greatest one? Greatest one is left side one. So we need to swap them. To do swap, we get in temporary value and store the first element value in the temporary value and assign second element into the first position. Then assign temporary value into the second position. Like this, we can get 34, 64, 25, 12. This is the first round. This is the first round. I is 0. I plus 1 in. I plus 1 is 1. Then we check 0, 1 and first one. Okay. Then second round. In this loop, second round, I get in number 1 and I plus get in number 2. Number 1 and number 2 mean we check 64 and 25. Now we check 64 and 25. What is the largest one? 64. That means it's the left side one. We have to swap them. Same as before. We swap them 34, 25, 64, 12. Now third term, J value comes number 2. First is 0. Second one is 1. Third one is 2. J plus 1 is 3. 2 and 3 mean this one and this one. 0, 1, 2, 3. 2 and 3. Then we have to check again what is the largest one. In this scenario, as same as before, 64 is the largest one. So we have to swap them from the swapping mechanism. So this getting 34, 25, 12, 64. Now we have got 3 rounds. J0, 1, 2, 0, 1, 2. 3 rounds. Loops going to n minus I times. I will display later again. This will stop at the 3 times. This will stop at the 3 times. Then stop this. Look, largest number came right corner. Largest number came right corner. From this top 4 loop, we now get in these 4 swapping. Not getting this because largest one comes to corner. Now we have to sort only this one. Same as before, we get 0, 1, 1, 2. Likewise, we get second largest one into the right corner. Likewise, doing this in the for loop, we can sort at the array by smallest to largest. This is the mechanism how bubble sort works. This follows for sorting nearby elements, couple of elements. This for loop for getting unsorted portion of array. Getting like this. Getting unsorted portion of array, we need this for loop. Second for loop need to sorted get largest value into the right corner. This is how bubble sort works. This is the code's example. This is how bubble sort works. Like that way, we can get sorted array list from the bubble sort program. Now I run this program. Yeah, the original array is 64, 34, 25, 12, 22, 11, 90. Sorted arrays come 11, 12, 22, 25, 34, 64, 90. This is how this works. So now I go into the talk about, we have talked bubble sort. We can talk insertion sort as well. Before that, I'll explain again. Imagine you have a stack of unsorted number of array unsorted array. We start by looking at the first two elements. If one of the left is bigger, we swap them. We keep doing this for every pair of numbers in the array. After one pass, the biggest number is at the right corner. We repeat the process, but we don't look at the right corner value at the each process. We keep doing this until all the elements ordered from the smallest to the biggest. Finally, we can get sorted array. That's how bubble sort works. Then we can move to the insertion sort. It works as different to the bubble sort way. First, I get the code example and discuss about it. This is the insertion sort code example. Let me explain same as previous one. Yeah. We have array like same as before, 64, 34, 25, 12, 22, 11, 90. In the array, in here, when we talking about bubble sort, they swap in couple of values, nearby values each by each, and doing same process again and again, then sort in the value. But in the linear search, it is known as sorry, linear search, not linear search, it's insertion sort. It's known as like can take it about talk it like it's works as, sorry. It's this algorithm like final sorted array one item at time. We have key value. I'll discuss it and explain it. We can take one value, one element as a key value, insert it into proper position. Like we get one value, we position in it. What should it has to position when it's sorted? Like way in the bubble sort, we get what is the largest, biggest one. We move it to right corner. In the insertion sort, we get one value. We check what is exact position it's need to need to position in it sorted array. We get it in that position. Like way. Do you understand? I think I do understand. In bubble sort, we get in bubble sort first iteration, we get what is the largest value and take it into right corner. But in insertion sort, we insert in the exact value in exact position what it need to position in when the array getting sorted. This is the difference between bubble sort and insertion sort. Bubble sort get biggest value into the right corner, but insertion sort doing get one value. It's called as key value. It's positioning in exact position, but need to position in sorted array. To do that, this is a Java code sample. I will explain that. Mm, clear this. I get 4 values same as before. 64, 34, 25, 12. This is a part of our array. First get variable name and array.length. Array.length mean there is a 1, 2, 3, 4, 5, 6, 7 elements. Then n is 7. In this graphical view, we get 1, 2, 3, 4. So n is 4. Okay. There's a loop. Getting integer I equal 1. Get variable I 1. Smaller than n I plus 1. That's mean integer key is number 1. Key is, I told before, we get a key value. Key is first iteration, key is number 1. Number 1 is 34. Integer key assigned equal ARRI, I mean number 1. 1 mean 34. 34 is a key. Then integer j integer j is I minus 1. Then I is 1, so j is 0. We get first iteration, we get key value as 34, and we get j variable, we assign it 64. 64 assigned to the j, because I minus 1 place is 0th place, like immediate place, we before the key value, immediate position, j is 64. Then we get while loop. If j greater than or equal 0 and array j means 64, I ARRJ means 64, j means 0. If j greater than or equal 0, now condition is true, and array j, which means value of the array 64 greater than key. If 64 greater than 634, we doing yes, 64, sorry, j greater than or equal 0, array j means 64, it's greater than or greater than key is now 34, yes, 64 greater than 34. So we need to swap, swap 64, because 64 is greater than 34. It's not 64 is not the exact place, it's need to get in this time, so we need to swap them. So we ARRJ1 means number 1 position, assign j, can we assign 64 into this place, 64. Okay, now j minus 1, j equal minus 1, because we decrement the value of j. Then we get the key j plus 1. Now j is minus 1. The key is j plus 1. J plus 1 means 0. Now the key is 0. 34, 25, 12. Let me explain again. We have unsorted array, integer n. We get variable n. To n, we put the length of array. In here 7, but in the graphical view we have 1, 2, 3, 4. So n is 4. Then the for loop work. We add the for loop. In the for loop, we get I variable. It's 1. I means 1. I clear it and explain again. This is our array. 64, 34, 25, 12. Now we have variable n, I, I, j. First iteration, n is 4, I is 1. We still haven't any j value. N is 4, I is 1. First iteration, we do integer key. We get key value as well. Key. This is also a variable. Integer key equal array 1, array I. Now I is 1, so key is 34. First iteration. We do in first iteration. Okay. Key is 34 because array 1 is 34. In the while loop, and j is I minus 1. I minus 1 means this is 0. Okay. There's a while loop. J greater than or equal 0. Now we check j greater than or equal 0. J is now 0. Yes, condition is true. And array j means 0th position 64. ARRJ means 64. 64 greater than key. Now key is 34. Yes, 64 is greater than 34. This condition also true. So now we can get into the while loop. While loop getting array j plus 1. J is 0, plus 1 is 1. Plus 1 is 1. That means 34. In this talk about 34. 34, sorry, array j 0 plus 1 means ARRJ position number 1. This increment in 1. Number 1, this position equal ARRJ because 64 is greater than 34. So now array change. This is not change because we do not do any. We don't need. We not change anything in 0th element. We just change first element to 64. Where's 34? 34 is the key. 34 is the key. Like bubble sort, we don't need swap because we don't need use temporary value. In here we use key value. It's 34. Now this is not change to L. This line works. The number 1 position change to the 64. This also 64. This is not change. These twos are not change. This thing is number 1 place change to 64. Now j change. J change to j minus 1. J minus 1 means j minus 1 means minus 1. Get minus 1. Now j is minus 1. Now again go to the while. J greater than or equal 0? No. The condition is false. Then we no need to check this as well because there is an AND operation. Then we break the while loop. Then we get into this line. Array j plus 1 is now the key. Array j plus 1 means j is now minus 1 plus 1 means 0. Array j plus 1 is the key. Key change to the 0th position 1. 0th position 1 is 64. 0th position 1 is 64. Next one. Key change to, let me explain again. We change the j value. J first is first vj. J now is minus 1. Sorry. J plus j now is minus 1. We check arj array j plus 1. J plus 1 means 0th position. J plus 1 means 0th position. ARRJ 0th position is 64 now. Now is the key is 64. Okay. Now we take into the next iteration to rather than bubble sort. We have to do a few more iterations to get clear idea. We get to the next iteration, then I is 2. First iteration I is 1, now I is 2. This is the second iteration. Now I is 2. Key is, now the key is array I. Again, key changed. Now the key is array I. Oh, sorry. Sorry. I do small wrong thing. ARR j plus 1. Sorry. We forget this second iteration. First iteration in last code line. I explain it again. J plus 1 means 0th position. We assign the 0th position to the key. Key is now 34. We add 34 to this line. Not we change key value, we change positions value. J plus 1 position values change into the key value. Okay. Sorry for that. We do not change key value. We change the j plus 1 position value into key value. Key value is still 34. Key value is still 34. We do not change key value. Still, we not change the key value. We change the j plus 1 position 34. Now is the array after first iteration 34, 64, 25, 12. This is the second iteration. In the second iteration, I get in number 2 because first iteration is I1, second iteration is number 2. Now key is array 2. Array 2 means this one, 0, 1, 2. Now is the key is 25. Now key changed. Key is 25. And get the j variable. J variable is I minus 1. I minus 1 means now j is 1. I is 2. Now j is 1. Then we move into the while loop. If it is while if it is j greater than or equals 0, yes, j is greater than or equals 0. Now j is 1. That means j is greater than 0. So condition is true. And array j means now j is 1. Array j1 means 64. Greater than key. What is the key now? Key now 25. Yes. Array j greater than key. That's condition also true. So we move into the while loop. Now array j plus 1. Array j plus 1 means now j is 1. J plus 1 means 2. Array 2 means now 25. Array 2 means 25. 0, 1, 2. We assign the array array j. We assign this array j plus 1 position. J plus 1 position is 2. We assign the j value. J value means 64. We now change the array 64 and 64. 12. Let me explain again. Array j plus 1 means j is now 1. J plus 1 is 1 plus 1, 2. 2 means this one, this position. Yes, this position, 0, 1, 2, this position. We assign array j value. Array j value means j is now 1. J plus 1 is 2. Okay. J is 1. Array j1 is 64. This value assigned to j plus 1 position. Then array change as this way. 34, 64, 64, 12. Okay. Then j equal j minus 1. J equal j minus 1 means now j change to 0. Again, we dive into the while loop conditions. If j greater than or 0, yes, is still greater than or 0. Key is not changed. Key is still 25. We are not problem. There is a 25 missing in the array because key is still 25. Now j is 0, condition is true. We look array j. Array j means 0th one, 34. 34 greater than key? Yes, 34 is greater than 25. Then the conditions are true. Then we get into the while loop. Array j plus 1. See, now j is 0. J plus 1 means this position. This position. This position equal array j. Array j means j is 0, 34. Now change the array 34. This is not changed. This change 34, 64, 12. Let me explain again. Array j plus 1 means j is 0. J plus 1 position is this position. 0, 1. We assign array j, this means 0, 1, 34 into this position. 34, 34, 64, 12. This is the updated array we have now. Now j value again updated, j equal j minus 1. Now j is minus 1. So while loop breaks. Now the while is breaks, and again we check ARR j plus 1. J plus 1 means now j is minus 1. J plus 1 means it's 0. Array 0th position. This position changed to key value 25. This change 34, 64, 12. Doing the same, we position in each iteration, the key value where it need to be positioned. Doing the same in again and again, we can get the 64 getting largest values getting right corners and smallest values getting left corner. It's how insertion sort works. Defer to the bubble sort. Bubble sort we get what is the we compared nearest values, nearest couple of values, and changing and getting largest values to the right corner. But in this case, we not doing this same its process. We just get key value. Each iteration we position in the key value in its right exact position. Doing same thing again and again, we can step by step change the orders of numbers according to the ascending order. This is how insertion sort works in programming way. Okay, I think you clear the things. Now I run the code. Yeah, this original array 64, 34, 25, 12, 22, 11, 90. Sorted array comes 11, 12, 22, 25, 34, 64, 90. I think all of you are getting the difference between bubble sort and insertion sort. Same as there are few more sorting algorithms, selection sort, merge sort, quick sort. Likewise, all of sorting algorithms there has their unique mechanism. We can choose any kind of sorting algorithm according to our purpose. What is our purpose? We can choose them. I can't explain what are the scenarios we need to select this sorting algorithm to specific tasks, because we have to talk about all of the sorting algorithms to take it. I can to discuss about this, but I can say this like this: the insertion sort and bubble sort, we are getting sort the small guide array element length is greater smaller than 20, like things. If we have more than if we have large amount of elements, we can't use bubble sort and insertion sort, because we have to check each element step by step. We searching and swapping, likewise we doing more operations when we have more elements in the array. This take more time. But if we have less number of elements in the array, this is a more efficient way, insertion sort and bubble sort, to do. If we have more number of elements in our array, there are some merge sort, quick sort. In this mechanism, I quickly explain and explain in little bit. We don't have much time to get code in example. In merge sort and quick sort, there is a mechanism like they separate the array. When we get like 100 elements of array, they divide into 50, 51. Then check where is the then again divide into 51 is 25, 25. Likewise, dividing getting dividing by dividing array, and again from the bottom of the separated arrays, they again rearrange the array into the sorted way. It is more efficiency in large set of numbers array, because if we had hundreds, 200,000 numbers of array, then we can divide it into two pieces by two pieces. Then we can collect them into ordered way. But if we have a small set of numbers, we don't need to doing separations, doing dividing the array, because there is a few number of elements. So we can use this kind of bubble sort and insertion sort. If you're interested in these types, just go through the internet, and there are a lot of resources. Just look at them, and what is the mechanism behind them, then you can get clear idea. Now we have to talk about bit on searching algorithm. This is sorting algorithms we have talked up to now. Sorting means we ordered some elements into ascending order or descending order, bubble sorts, insertion sort, selection, merge, likewise. But we need to search any exact value from a array or some kind of data structures. We need searching algorithms as well. There are many algorithms, searching algorithms, same as sorting algorithms, like linear search, binary search, breadth search, likewise. So when we talk about linear search, it's also known as sequential search. It iterates through collection of data from beginning to the find desired item, suitable for small kind of database like bubble sort and insertion sort. Then when we talk about binary search, it is used to sort at arrays. When we in binary search, if we had time, I'll explain in code example as well. But I explained these two. Linear search is known as sequential search. It's iterate the data set at the beginning, from the beginning of the to find the desired item. It's suitable for small data sets. In the binary search, the second one I discussed, it's applicable for sorted arrays, because it works same as that merge and quick sorts I talked. It's works as it's dividing the array into it's dividing array to two. Then check it is sorted array. Then we can check if there is when we get some graphical this view, we have set of numbers like sorted array. This is our sorted array 64. Sorry, not 64. 11, 12, 22, 25, 34, 64, 90. This is our sorted array. Binary search is applicable for sorted arrays only. In here, what's the mechanism is we divided this We think we divided these two in separated. We need to check 64. We need to search 64 value 64. First, we divided them into two separate arrays. First, check is this same as 24? No. Then we check this one greater than 64 or this one. That can get idea. We can get idea if it is 64 in this portion or in this portion. Then we can reject one portion from the two portions. Same as again, we in the for loop, we again divided this into two parts, then check middle value and then check two portions. From the two portions, we can reject one portion. Likewise, we can check what is the where is the exact value is in the array. So this binary search is applicable for some kind of large amount of data sets rather than linear search. Linear search just look in beginning from to the beginning to where is the our desired value is located. But in binary search works as like quick and merge sorted ways. This mechanism I call mechanism, not same as the sorted way. The same mechanism used in binary search, just dividing, searching what's the portion should this value be consist, then choose the portion, again divide, again searching, again divide. Likewise, we can search the exact value where is the located. We not need to search one by one like linear search. In binary search, we can reject portion by portion and search where is the exact value is located. This is how searching algorithm works. I do not take much time to get coding examples because it's not possible as well in this limited time to get more big picture of coding sample. I just explain you what is the mechanism behind these two searching algorithms, and as well I talk about two sorting algorithms. What is the mechanism used them? Then I'll move to my slide. What's next we have to talk? Yeah. When we working with algorithms, we have to do proper analysis based on our algorithm, because we can do in the basic introduction of algorithm is a step-by-step guide how to perform a task, a specific task, or a specific thing in a software program. So we can compare to we can think things in different ways. Like I can think something in some way, then you can think in something in some way. So our instructions can be different for exact specific problems. Your instruction set can be different, and my instruction can be differ to each others, because it's basically based on our thinking pattern. So we need to analyze our algorithm. If this is the best algorithm, we can solve this exact problem. So to do this, we can use big O notation to measure in algorithm complexity. Big O notation means I don't take much time to explain this. You can dive into this by internet, by using internet resources, but I get you a clear picture about this. Big O notation means measuring algorithm complexity. There is we can be if there we use two loops, there is a marks. For one loop there is a mark, two loop there is a mark. If we use nested loop, there is a mark. If we use if else block, switch case blocks, there is a mark. Based on the marks, we can get total marks. It's a same kind of mechanism we do in big O notation. Based on that mark, we can measure the algorithm complexity. We can measure the algorithm complexity based on that marks. There is some guidelines on big O notations. So dive into that in from your lecture notes or something else. But I tell you what is the big O notation is measuring algorithm by giving the marks what we use in the algorithm. Then we can get idea about the complexity of algorithm, and we have to we can measure them in our worst case and best case. Worst case, best case, average case means when we get some searching algorithm. Best case is the searching value is in the top first element is the best case. We don't need to go more. Is the first element is the best case in the linear search. So linear search is binary search. It can be a worst case, but in linear search, when there is a when the value is in the front of the array, it is the best case. If the value is last element is the worst case, then we have to perform our algorithm more and more. So the complexity differ to the this situation: worst case, best case, average case. So when we analyzing the algorithm in such as cases by using big O notations, we can exactly know how is our algorithm perform, what is the complexity of algorithm. If this is the best algorithm we can use, or we can select another one rather which more less complexity by using this algorithm analysis techniques. Big O notation is the one thing. There are many things to we can analyze algorithms, but in mostly use the big O notation things to analyze the algorithms what we use in our programs. This is the sorting algorithm commonly used in bubble sort, insertion sort, quick sort. We have discussed about bubble sort and insertion sort. Searching algorithms, linear search, binary search. We discussed linear search and binary search, and we not doing implement a code. There's another algorithm, graph algorithm, dynamic programmings, but we talk about sorting and searchings only. Yeah. I think this session series is based on or you have hackathon nearby. I think I just guess. So this is the very important part. The data structures and algorithm to do in programming. Basically, mainly on do in your university life. You are all you are participating in hackathons. Then the data structures are algorithms are most important things, because hackathons are mainly based on problem solving. So to do problem solving, we need to do best problem solving. To find a best solution for problem, we need to choose what is the best data structure, what is the best algorithm we need to perform on our problems. So this part is very important part for solving complex problems. So more reference, I recommend use HackerRank like things to solving algorithm challenges, to optimizing your problem solving skills with using the data structures as well. So I think we covered some areas: data structures, algorithms, and optimizing the algorithms. In data structures, we talk about 4 types: arrays, linked list, and talk about some operation or need array insertions and linked list insertion, deletion, and stack pop push operations, and queue enqueue dequeue operations, and also algorithms. We talk about searching algorithms and sorting algorithms. In sorting algorithms, we talk about bubble sort and insertion sort, and searching algorithm, we talk about linear search and binary search. So this is the content. We have a summary of the uh, lessons plan we have talked in these 2 hours. So I think this is the end of our session. Yes, it's the end of session. If you have any question, can you ask them, or can you put them in chat? We have few. Can we get few more minutes? Sadi, if we do we have any question from the end?
Yes, yes, we do.
First one is how to identify which data structure best suit a certain problem. First, we need to dive into the data structures, how they perform, what is the exact difference with other data structures. Like we talk about linked list and array. Then I told we can the arrays we have fixed size, but linked list we do not have fixed size. But array is very fast because we can access elements by using their addresses. So if we know the exact element we need to store, we can use linked list. Sorry, array list. That's the way how we identify what is the suitable data structures. We have five. We exactly know there is a 5 elements. We don't need to exceed them, so we can use just array list. If it's the scenario we don't know about how many number of elements we need to use, we can't use that data structure. Let me get a real world example. In the supermarket queue, sorry, not a queue, in the supermarket, the cashier don't know how many products you will buy, so we can't get uh, fixed number data structure for save the products. To do is transaction, we can't get fixed number data structure. We need to get adjustable data structure, because cashier don't know about how many products you get. They can't restrict you only get 5 products. They can't talk about that. So that's how we identify which is the data structure best suits for certain problem. First, you need to get better understand about data structures. What is the scenarios? How can we use? What is the difference between them? Then you can identify what is the best data structure for your purpose. When you look at question, where do you start from for solving a question, like check code or working? Yeah. And the other question is, when you look at question, where do you start from for solving the question? Like check what algorithm to do or something like what? I do the same thing. Don't try don't try the first time in the code level. Just brainstorm this. What is the actual problem? What are the inputs in there? Then the example is the example was we have two numbers, we have to get largest number, then check out what is the inputs, then check out what is the output. Output is largest number, input is we have two numbers, then check what is the process you need to perform. We need to check what is the largest number. There can be several processes, there can be several outputs, there can be several inputs. In that way you can break out the problem into small kind of things, and you have inputs there, you have outputs there, then you have to use the algorithm skills to solve the problem by getting inputs and converting to output. That's the way. First you clearly understand what are the inputs, then you clearly understand what are the outputs, then you identify what are the processes you need to perform to get output from these inputs. That's the way you want to you can solve a problem from the beginning to the end. Array class in Java, there is a sort method, right? So we can use that method, is right? Yeah, yes, right. Every frameworks and every language we have methods already built in, but the purpose of learning those things is my experience also. There are in my university times there are batchmates, some of them are doing uh, web web services and mobile application. Till my third year I don't good skills in doing any kind of, not only me, some of my best some of good best results persons, they have not good experience in doing real-time application, web application or mobile application, but they dive into core things, how the sorting things works, how the searching things works, how the algorithms works, what are the data structures, how they works. By the learning core things, you can simply dive into simple. There's the method, calling method is a simple thing, but you have to get knowledge about how this works, then you can work on it. Would you recommend using print statement in between codes to check if all the parts of the code are working? If not, any other ways to debug the code? It's depend on framework that you work. Printing statement is not best practice actually. Depend on framework, there are debugging. There is a debugging facilities, differ to language, framework to framework, platform to platform. So using print statements is not good practice, but sometimes we have to, some platform we have to use this printing statements or console logs. But if there is a, if you have any debugging facility, use this, don't use statements like this. Yes, data structures affect the efficiency. When we talk about sorry, arrays and linked list, if we want to check, we have a small set of data, we have to access them fastly. So but we know fixed size, then we can use array. But if we choose linked list, this small kind of data, we think 10 or 11, 12, 13 kind of data, when we addressing the middle element, we have to go through the one by one to access them. But we use array, we can directly access them. So this is the way how affect the efficiency by the data structures we use. What are some good website resources and data structures more in depth? Actually, I exactly don't know. You can use tutorials point and other basic stuff. There are good tutorials in there, and you can use AI as well, chat GPT or something. Actually, this presentation I made from AI. I know the context. I created this presentation by using AI technology. So then, can I, by the knowledge of mine, I can go through these points. You can use AI technology, chat GPT or other things. It's good. How important is to know data structures, algorithms to get in intern? Not only for intern, every basic beginners who enter to the software engineering and IT computer science field, that is essential and most important things beside programming. To do programming is actually, to do programming we need data structures and algorithms. It is a high priority one. Do not think about this is not important as beginner or as intern. As the beginner, we know this data structures and algorithms we need to learn in beginner level. Actually, what is the best way to master data structure and algorithm? Good question. To be a master of algorithm, to practice hacker rank, there's some kind of challenge platform. Hacker rank is the good platform. Actually, I don't use it since last year, since a few years, but as you learning those things in university, as usually university students use hacker rank and other platform, day by day. It's reserve 1 or 2 hours for doing some kind of hacker rank or things. It's very good practice to be a master of data structures and algorithm. Complexity of these algorithms, actually I discuss it bit. Big Go, if you want more, go through the big Go notation things. As I explained, what are the structures we use, how many for loops, how many nested loops, how many if else blocks, how many switch case blocks. By using these, we give it the measurement. By using this measurement, we can check what is the complexity of this algorithm. I not more discuss about those part. Please go through the resources and get more about it. Any advice on how to use data structures and algorithm to solve problem during programming, competition or coding interview? It's based on your experience. Experience means using them in as mentioned before, use hacker rank and other things. Using this practice, eventually you can get the idea of what are the base suitable data structures, algorithms to solve problem. It's not get from one night. You need to practice them, you need to experience them. That's how we can choose how we can sense what is the best data structure and what is the best algorithm can be used to solve problem during programming competition or this coding interviews. Yes, I think all question I answered. Sadi, over to you. Thank you, all of you. I think you all get something from my session. Thank you, all of you. Sadi, over to you.
Yes. Thank you, Mr. Nirmal, for that inspiring session, which enriched us with knowledge on data structures and algorithms and enlightened on us on how to be efficient problem solvers, and for taking the time to address all of our queries. And surely these clarified all of our viewers' doubts. So now let's take a moment to acknowledge our invaluable partners without whom this event would not have been possible. Our gold partner, Cosent, specializes in UX research and design, prototyping, building SaaS and mobile products, and cloud engineering. Our bronze partner, WSO2. WSO2 enables fast and secure digital experiences through open source and SaaS technologies. Our workshop partner, IFS, delivers award-winning solutions for businesses aiming to excel in customer service, especially during their moment of service. Our technical partner, Luxury X, renowned as the best sellers of Apple products at affordable and reasonable prices. Next up, our digital media partner, Now You See Me, provides a variety of digital media services such as event photography and video production. And our knowledge partner, STEMlink focuses on boosting proficiency in school subjects. And finally, our venue partner, ExactPro. ExactPro excels in quality assurance and test automation for trading and post-trade systems. We extend our heartfelt gratitude to each of these companies for collaborating with us and helping bringing our ideas to life. Now, there's an exciting announcement to share with our coding enthusiasts. We are excited to announce that the registration deadline for IEEE Extreme 17.0 has been extended until the 18th. So you can now find the registration link in the chat. So spread the word, invite your friends, and join us at IEEE Extreme 17.0. On behalf of the organizing committee, we extend our deepest gratitude to Mr. Nirmal for your enlightening contribution. We hope you accept this virtual token of appreciation for the invaluable knowledge you shared with all of our participants today. As we've now come to the end of our session, I'd like to extend our heartfelt gratitude to everyone who joined in today. Your participation is greatly appreciated. We hope today's session has been a valuable experience and that each and every one of you has gained a deep understanding of the key fundamentals of data structures and algorithms. Once again, thank you all for being with us today, and we hope you all have a great night ahead.